Associate Professor of Department of Marine Engineering. Now I am going to give a lecture on PN junction diode. So actually, PN junction diode is made from the P-type and N-type semiconductors taken separately, and they are joined by a process called doping. Actually, P-type material is composed of holes and N-type material is composed of fully of electrons. In P-types, majority carriers, as I already said, P-type material, majority carriers are holes and minority carriers are electrons. In N-type material, majority carriers are electrons and minority carriers are holes. And they are joined by the process called doping, a special process for the manufacturing of diodes and thyristors and all. And a PN junction is a device formed by joining P-type and N-type semiconductor and are separated by a thin layer called PN junction depletion layer or the junction. And this is the symbol for the PN junction diode. Here the triangle represents the P-type and the horizontal straight line represents the N-type. Usually the P-type will be in the left side and the N-type will be on the right side. And before giving any external connections, the excess electrons in the N regions, that is the majority carriers, cross the junction and combine with the excess holes in the P region. Likewise, the excess holes in the P region will be combined to the N-type electrons. So, N region now becomes positively charged and P region now becomes negatively charged. And the depletion layer contains no free electron but only fixed and immobile ions. So, it depends upon the doping level. If the material is of heavily doped, the depletion layer is thin, and if it is lightly doped, the depletion layer thickness is very high. The electrons in the N region have to climb the potential hill in order to reach the P region. So the electrons trying to cross the N region to the P region experience a retarding field of the battery and therefore repelled. Similarly for holes from the P region. So the potential thus produced are called barrier potential. Usually this PN junction diode will be made by using germanium and silicon. So the potential barrier for germanium is 0.3 volt and for silicon is 0.7 volt. And this is the diagram for the forward biased condition. So in the process of making the PN junction to conduct, there is a two biasing mode. One is forward bias mode and the reverse bias mode. In the forward bias mode, the positive terminal of the battery is connected to the P-type and the negative terminal of the battery is connected to the N-type. So here, it forces the majority charge carriers to move across the junction, decreasing the width of the depletion layer, and the movement of electrons passes easily, and this this improves the flows of the current. And in the reverse bias condition, it is opposite to that of the forward bias condition. That is, the negative of the battery is connected to the P-type and the positive terminal of the battery is connected to the N-type. And here, the thickness of the depletion region will be very high and it does not conduct the flow of current. And the current is of the order of only microampere, that is because of the minority carriers present in the P and N-type material. So, in the reverse bias condition. And this is the general VI characteristics of the PN junction diode. And the x-axis is taken as voltage and the current is taken in the y-axis. And during the forward bias, as I told, after 0.3 or 0.7 volt, depending upon the material, it starts conducting. And during the reverse bias condition, it doesn't conduct the flow of current. After the full breakdown, either Zener breakdown or avalanche breakdown occurs, in the reverse bias condition, it starts conducting. So at that time, the full diode will be getting damaged. It cannot be used as a diode. So this PN junction diode can be used in the forward bias only, not in the reverse bias. So in the reverse bias case, it acts like a off condition switch. In the forward condition, it acts like a on condition switch. And these are some of the advantages. Here, no filament is necessary and it occupies less space and the life of the diode is very high. And main applications, it can be used as rectifiers in AC and DC circuits, and it can be used as an amplifier. Mainly, the PN junction diode can be used as a switch for on-off the circuit. Thank you.